Today let's go ahead and discuss an introduction to algebraic functions. The idea of a function in math is any expression that includes input. That input is put into a situation that will change the looks of the input, and out will flow the output. Now, functions can be ordered pairs. Just make sure that each x relates to one and only one y. Look at the example here. We have the x of 4 and it relates to the 3. It is actually combined or joined with that 3. Then we have a different x of 6 and it is joined or combined to that 4, y value. Then we have the third and final x and it is a 7 and it is joined to the y value of 7. So would this be a function? Yes, because we can see that the domain, which would be the x values, remember that the word domain means x values, they are 4, 6, and 7, all distinct, unique. And the range values are the y values in the ordered pair. They are 3, 4, and 7. The range values do not have to be different, but those domain values do. Here's a second example. Notice in the first ordered pair, the x is 5 and it goes with another 5 for the y. But the second ordered pair also has the x of 5. That cannot happen in a function. So no, this is not a function. If you think about it, the domain value, or the x values, would have been 5, 5, 6, and 6. Those are all the x values. We don't normally write them twice like that. We would just say 5 and 6 would be the domain, but because they are duplicated, it is not a function. Those numbers cannot be duplicated in the domain, or the x. The range value will always simply be the y values, which in this case would also be 5 and 6. So functions can be ordered pairs. Functions can also be equations. Just make sure that each input value, or the x in the equation, must yield one and only one output value. So let's try it. Think of a number. Let's maybe let x equal to -1. And let's just plug that -1 into the x value and solve it. So we'll have -1 squared plus y equals 64. Well, -1 squared is 1. And if I solve for y, how many answers do I get? I get only one answer. So one value for x yielded one answer. Then yes, this is a function. In the second equation, let's try the same thing. Let's let x equal -1 and substitute that into the x value. So I have -1 squared plus y squared equals 36. Well, again, that's just +1 plus y squared equals 36. Let me subtract that 1 out of there. I get y squared equals 35, and I have to use the square root method to solve. So I get y equals plus or minus square root 35. It does not simplify. But remember, plus minus means I have two answers. No, you should not get that with a function. You should have one answer or one output for each single input. So this second example is not a function. But functions can be equations, as you saw in the first example. And last but certainly not least, functions can be graphs. They just must pass the vertical line test. The vertical line test says, if I draw a straight vertical line, it must cross at only one point. So if a line crosses at one point on the graph that's given, then it is a function. Now, not all graphs will be functions. Look at this graph of just a box. If I draw a vertical line here, notice that it crosses that blue box in 2 places. So this is an example that is not a function. But graphs can be functions if they pass the vertical line test. The next things to know about functions would be function notation. We are used to saying y equals 2x. Now we're going to say f of x equals 2x. Notice that I read that as f of x. The f is the name of the function. So we can work with various equations at one time. The x is the input. And the answer I get, which is down here, that is my output. Now notice if I let x equal 5 in either equation given, whether it's written the old way or the new way with function notation, the answer is still the same. It's 10. Now let's try one of these from the homework and try evaluating with the function notation. This one is in 3 parts. First, I will let the x value or the input be -6. Well, in reality, there's no x. It's really the variable r. So f of -6 would mean I take the -6 and I substitute it in place of that variable r. Well, -6 plus 6 is 0, and the square root of 0 is 0, and 0 minus 4 is -4. So we would say that the answer here for part A is -4. It's just simply a matter of substitution. Now for part B, we'll use the value 10. So f of 10 is equal to the square root of 10 plus 6 and then minus 4. Well, 10 plus 6 is 16. The square root of 16 is 4. And 4 minus 4 is equal to 0. So when the input value is 10, in this case that's really the r, then we end up with the output or the answer of 0. Last one, part C. This time we want to substitute in an expression, x minus 6. This entire thing is my input. So I will just substitute that underneath the square root symbol. I have x minus 6, and then I'll have the plus 6, and then I'll have minus 4 outside the symbol. Well, notice that the -6 and plus 6 would be 0. So that just leaves me the square root of x minus 4. I cannot simplify, so that would be my final answer. My answer then is the expression square root x minus 4. Hope you enjoyed this section on functions.